Like we said yesterday, we did 2.2, solving inequalities using addition and subtraction. Today we're going to solve inequalities using multiplication and division. Yesterday, was there really anything different between solving equations and solving our inequalities? No. We did it exactly the same as we did our equations, correct? Today, when we're using multiplication and division, everything's the same except for one thing. There's one extra thing that I have to do under certain circumstances, and we'll talk about that here in just a few seconds. So, right here I've got this chart, this table. I've given you an inequality. 2 is less than 5. Everyone agree that that's a true statement?
Yes.
2 is less than 5. We're going to do all these operations to each side of the inequality. Okay, and we're going to look at stuff that happens on certain occasions. So, 2 is less than 5. If I add 7 to both sides of the inequality, what's 2 plus 7? 9. What's 5 plus 7? What's 5 plus 7? 12. Is my symbol still going to be less than, or is it going to be greater than? Less than. So that's how we're going to go through this whole table. We're going to do our operation to both sides, and then you guys are going to tell me if it's less than or greater than. Everyone understand how we're doing this? You can if you want. Okay? I've got a certain goal behind it as to why I'm doing this table. So if you just want to pay attention, that's fine as well. Okay, let's divide both sides by 3. 9 divided by 3. 3. 12 divided by 3. 4. What's my inequality symbol going to be? Less than. Everyone okay with that? Now we're going to subtract 3 from both sides. What's 3 minus 3? 0. 4 minus 3. 1. What's my symbol? Less than. Nothing's changed so far, has it? Besides the numbers on each side of the inequality. Okay, let's add negative 5 to both sides. So what would 0 plus negative 5 give me? Negative 5. What about 1 plus negative 5? What would that give me? Negative 4. What would my inequality symbol be there? Still less than, right? Now let's subtract negative 10. We're subtracting negative 10. If I have two negatives right next to each other like that, it becomes a positive. So I'm essentially just adding 10, right? So we're adding 10 to both sides. What's negative 5 plus 10? What do we say? 5. What's negative 4 plus 10? 6. What's my inequality symbol? Less than. Let's add 11 to both sides. What's 5 plus 11? 16. 6 plus 11? 17. Symbol? Less than. Everyone still with me? All right. Let's subtract 6 from both sides. 16 minus 6.
Teachers, please pardon this interruption.
So what's 16 minus 6? 10. 17 minus 6. 11. What's my inequality symbol? Less than. Still with me? All right. Let's multiply both sides by negative 2. What's 10 times negative 2? Negative 20. What's 11 times negative 2? Negative 22. What's my inequality symbol? What? Greater than. Uh-oh. Something happened. Something changed, didn't it? All right, let's keep going. Let's add 16 to both sides. Negative 20 plus 16. Negative 4. Negative 22 plus 16. What? Negative 6. Inequality symbol. Is negative 4 greater than or less than negative 6? Greater than. Now my inequality symbol started to stay the same, didn't it? Now let's divide both sides by negative 2. Negative 4 divided by negative 2. Can't hear you. Negative 4 divided by negative 2. 2. Negative 6 divided by negative 2. 3. Inequality symbol. Less than. Uh-oh. Something happened. It flipped again. Let's add 8 to both sides. 2 plus 8. 10. 3 plus 8. 11. What's my symbol? Less than. It's staying the same again. Multiply by 2. 10 times 2. 20. 11 times 2. 22. Symbol. Less than. It stayed the same. So what did we notice here? Did we notice anything in particular? Say it again. When did it change? When did my inequality symbol flip? Not when we subtracted 6. Multiplied by negative 2. And what else? Nope. When we divided by negative 2. Right? It flipped when I multiplied by a negative number. It also flipped when I divided by a negative number. That's what I was wanting you to catch. When I added a positive, it stayed the same. When I added a negative, it stayed the same. When I subtracted a positive, it stayed the same. When I subtracted a negative, it stayed the same. When I multiplied by a positive, it stayed the same. When I divided by a positive, it stayed the same. So the only time my inequality symbol flipped was when I multiplied or divided by a negative. Does everyone see that? Any other time it stayed the same. When we're solving our inequalities today, any time I multiply or divide both sides of the inequality by a negative, my inequality symbol will flip. Does that make sense? Because it's changing both of the signs on both sides of the inequality. Right? Here we multiplied 10 by negative 2. So that changed that to a negative. It also changed my 11 to a negative. The 11 was originally bigger, but whenever both things come to the negative side of things, the bigger a negative number is, actually that's a smaller number, right? Like negative 22 is less than negative 20. Does that make sense? So anytime we multiply or divide both sides by a negative, we've got to flip our inequality symbol. Everyone get that? You may want to write that down on your notes. Anytime you multiply or divide both sides of an inequality by a negative, your inequality symbol flips. I'll say it again. Anytime you multiply or divide both sides of your inequality by a negative, your inequality symbol flips. One more time. Anytime you multiply or divide both sides of an inequality by a negative, your inequality symbol flips. Everyone got that? If I multiply or divide by a positive, it stays the same. Anytime I'm adding or subtracting any number, it stays the same. Only when I multiply or divide both sides by a negative. So that's all. Well, actually, that's not what this is saying. This is saying what our addition and subtraction rule said yesterday. If I multiply both sides of an inequality by a positive, it produces an inequality, an equivalent inequality. I can't talk today, I'm sorry. So that's all this slide is saying. Anytime I multiply or divide by a positive, I get an equivalent inequality.
At this time, I need seniors with the last name beginning with the letter A to come to the library to take their cap and gown photos. Thank you.
So, let's look at some examples. Letter A. X over 8 is greater than negative 5. So, very, very similar to solving an equation, still using inverse operations. We just now have to keep in mind that any time we multiply or divide both sides by a negative, our inequality symbol flips. So, in this case, how would I get x by itself? If x is being divided by 8. Multiply both sides by 8. Bless you. Bless you. Negative 5 times 8 is going to give me what? Negative 40. Does my inequality symbol flip or stay the same? Why does it stay the same? Because I've got a negative 5 on the other side. Very good. Both sides have to be multiplied by a negative in order for me to flip it. We multiplied both sides by a positive 8, so it stays the same. Here's my solution. X is now by itself. Any questions how we got that? So any number that's greater than negative 40 is a solution to my inequality. It does want us to graph it, so we're going to graph it. How many numbers do I want on your number line? At least 5. Open or close circle on negative 40. What? Open. Negative 40 is not included in my solution set. It is not or equal to. There's no line underneath that inequality symbol. Shading to the left or the right? To the right, I want values that are greater than negative 40. So that'd be to the right. Questions on letter A? We good there? Can I erase and move to B? Letter B. Negative 24 is greater than or equal to 3x. Raise your hand if you can tell me how I'd get x by itself.
Divide both sides by 3.
Very good. X is being multiplied by 3. Inverse of multiplication is division. So I'm dividing both sides by 3. Negative 24 divided by 3 gives me negative 8. I'm left with just x on the right-hand side. Does my inequality symbol flip or stay the same here? Stays the same because I divided both sides by a positive number. Everyone okay with that? Open or close circle on negative 8. Closed. It has that line underneath my symbol. Negative 8 is included in my solution set. Am I shading to the left or the right here? What? Right? It is the left. When's the only time you can follow the rule of the way the arrow is pointing? When the variable is on the left side. So, is my variable on the left here? No, so I cannot shade whichever way the arrow is pointing. If I want to do that, I've got to rewrite it with the x on the left. Now, which way is the arrow pointing? To the left. I know I'm shading to the left. I also know that I want values that are less than or equal to negative 8. So that'd be to the left of negative 8. Questions on A or B here? Can I move on? Okay. I'm going to leave it up to you guys. Do I need to do any of these examples on this slide? I can do any or all of them if I need to. All of them? Okay, let's do all of them. Number 1. N over 7 is greater than or equal to negative 1. How would I get n by itself here? Multiply by 7 on both sides. Because n is being divided by 7. Negative 1 times 7. Negative 7. Symbol, flip, or stay? Stay. Both sides got multiplied by a positive, so it's staying the same. Open or closed on negative 7? Closed. Shading which way? To the right. Questions on 1? Are we okay with the graphing at least?
Yeah.
Open or closed circle and deciding which way to shade? Y'all okay with that? Are we okay solving so far using addition, subtraction, and multiplying or dividing by positive numbers? Okay. Number 2, negative 6.4 is greater than or equal to 1/5 W. How would I get W by itself in this case? Yep. W is being multiplied by 1/5, so I'm dividing by 1/5 on both sides. So negative 6.4 divided by 1/5. Can someone tell me what that is? Be some negative number. What do we get? I can do it too if I need to, I guess. What did we say? Negative 32. Symbol, flip, or stay? Stays the same. W is now by itself. Open or close circle on negative 32. Close, shading which way?
To the right. To the left.
To the left. If you need to, flip it around to where the variable is on the left so you can follow whichever way the arrow is pointing. Questions on 2. Number 3, 4b is greater than or equal to 36. How do I get b by itself? Divide both sides by 4. 36 divided by 4? 9. Symbol, flip, or stay? Stay. Open or closed on 9?
Close.
Closed. Shading which way?
Right.
To the right. I want values that are greater than or equal to 9, so that'd be to the right of 9. Questions on 3? Feeling good about this so far? Last one on this slide. Negative 18 is greater than 1.5q. How would I get q by itself? Divide by 1.5 on both sides. Negative 18 divided by 1.5 gives me what? Negative 12. Symbol, flip, or stay? Stay. Q is now by itself. There's my solution. Open or closed on negative 12? Open. Negative 12 is not included in my solution here. Shading to the left or the right? Left. Once again, if you need to, flip it around with the variable on the left. Any questions on these 4 examples? Feeling okay about it? Can I move on? Okay, this slide, all it's saying is what we said earlier. Anytime we multiply or divide both sides of an inequality by a negative, what happens? Our inequality symbol flips. If it's greater than, it flips to less than. If it's less than, it flips to greater than. Same thing if it has the bar under it. If it's less than or equal to, flips to greater than or equal to, and vice versa. Anytime you multiply or divide both sides by a negative. Am I good to go past this slide? That's all it's saying. Okay. So let's look at some examples here. 2 is less than y over negative 3. 2 is less than y over negative 3. Raise your hand if you can tell me how I get y by itself here. Maggie? Multiply by negative 3 on both sides. Negative 3 times 2. Negative 6. I've got y on the left. Symbol flip or stay. Why does it flip? Both sides of our inequality got multiplied by a negative number. So we have to flip our inequality symbol. Open or close circle on negative 6. Open. Shading which way? What? To the left. Like I always say, if you need to, put the variable on the left so you can follow that rule of whichever way the arrow is shading, or whichever way the arrow is pointing. Okay, letter B. Negative 7y is less than or equal to negative 35. Raise your hand if you can help me out here solving this inequality.
Divide negative 7, then negative 35.
Very good. Y is being multiplied by negative 7 using the inverse operation of division. Dividing both sides by negative 7. What's negative 35 divided by negative 7? 5. Symbol flip or stay? Flip. I divided both sides of my inequality by a negative. So I've got to flip from less than or equal to greater than or equal to. Anytime you multiply or divide both sides of the inequality by a negative, you must flip your inequality symbol. Open or closed on 5? Closed. 5 is included in my solution set. Shading to the left or the right? Right. I want values that are greater than or equal to 5. Questions on B here? We good with that? Can I move on? Okay, I've got a bunch of examples on this next slide. We can do some, none, or all of them if we need to. There's 6 examples here. Do we need to do all of them? I can go through them all really quick if I need to. Or if I need to just do some of them, I can. What do you guys need from me here?
All of them.
Do all of them? Okay, let's do all of them. We're not going to graph them. Okay, are we all good with graphing at least? Am I good to skip the graphing part? Okay.
Do we have an assignment today?
Huh?
Do we have an assignment?
Probably. P over negative 4 is less than 7. How'd I get P by itself here on number 5? Multiply both sides by negative 4. 7 times negative 4?
30.
Negative 28. Symbol flip or stay?
Flip.
Flip. We multiplied both sides by a negative, so it's got to flip. Questions on 5. Number 6. X over negative 5 is less than or equal to negative 5. how would I get x by itself in this case?
Multiply by -5.
Multiply both sides by -5. -5 times -5 gives me 25. Symbol flip or stay? Flip. Multiplied both sides by negative, so it's got to flip. We getting the concept here? Number 7. 1 is greater than or equal to -1/10 z. How would I get z by itself? How would I get z by itself here? If it's being multiplied by -1/10.
Divide by -1/10.
Divide both sides by -1/10. One divided by -1/10 gives me -10. Good job. Symbol flip or stay? Flip. I divided both sides by a negative, so it's got to flip. Questions on 7? Number 8. -9m is greater than 63. -9m is greater than 63. How would I get m by itself? Divide both sides by -9 because m is being multiplied by -9. 63 divided by -9. I think we need to go back and do our times tables. Symbol flip or stay? Flip. Divided both sides by a negative, it's got to flip from greater than to less than. Number 9. -2r is greater than or equal to -22. How would I get r by itself? Divide by -2 on both sides. -22 divided by -2. 11. Symbol flip or stay? Flip. R is less than or equal to 11. Any number that's less than or equal to 11 is a solution here. Lastly, number 10. -0.4y is greater than or equal to -12. If y is being multiplied by -0.4, how would I get y by itself? Divide by -0.4 on both sides. -12 divided by -0.4 gives me what? Say it again. It'd be a positive. Positive 30. Is that what everyone's getting? Symbol flip or stay? Flip. Questions on 10? So, everything else is the same as solving equations, right? Still using our inverse operations. Whatever we do to one side, we have to do to the other side as well. The only difference is when I multiply or divide both sides by a negative. And what's the only thing I have to change on that? If I multiply or divide both sides by a negative, what do I have to do? Flip the inequality symbol. That's the only difference. Everything else is exactly the same as solving an equation. Okay? If it asks you to graph it, I do want you to graph it. So make sure you're paying attention to the directions on your assignment. Are there any questions about any of the notes we just went over? We good? Okay, you'll get your assignment tomorrow in class.